I mentioned preferences. This is going to be a formal algebra. I'm going to go over a formal algebra of preferences drawn from Osborne and Rubinstein's text, and then we'll discuss the properties that are commonly assumed of these preferences, which will justify much of what's coming next in the classical economic model of let's say, utility maximization. Okay, so preferences, all of this notation, in fact, comes from set theory. Just giving a little background. So we talk about certain sets being contained in other sets. And that's why the notation looks a bit different than what you might have seen before. Okay, so first of all, I'm going to discuss things in two ways, maybe second of all. I think I already said first of all. We're in the text and in my notes, we discuss things in two ways. We discuss the properties of what are called relations in general, and this is a mathematical concept. So we have relations like greater than, less than, equal to, contained within, not contained within, etc., etc. And we can discuss what are the properties of these relations. If you've taken even maths in elementary in school, you've probably heard a little bit about some of these properties of relations, like transitivity. And this is very much both, well, some of this is set theory and some of this is very much logic, but actually, logic actually is based on set theory. Maybe I'll record a video, or mention that to some extent. Like with logic, we think about things like if x, then y. So if I say if x, then y, that's equivalent to saying if not. This means, okay, this is a little bit confusing because we reuse this notation differently. So I'll say if not x, then not y. I'm using let me just write it as not, because we're reusing some of the notations here. Not x, then not y. Okay, how do I know that holds? Well, saying if x, then y is basically saying that the set of things where x is true, this here, is contained within the set of things where y is true. This larger set here. So, I mean, I could be a little bit more formal, but graphically, I can see that if we have a situation where x is contained with y, is contained within y, that means whenever x occurs, whenever something's x, so for instance, whenever someone is a person, they're also an animal, it means that, okay, this is incorrect. Everyone makes mistakes. Okay. What's implied by this is not true. What's implied by this is what's called the contrapositive. If not, x implies y itself implies not y implies not x. Okay, so in other words, if I'm outside of y, I certainly can't be within x. So if I'm not an animal, then I'm not a human. So this is talking about the connection between logic, set theory, and set theory being behind preferences. Okay, that was a little bit of a diversion there. But what I want to do is talk about we're introducing you to the algebra of preferences, or the notation for preferences. We'll talk about different preference relations, which themselves are also mathematical relations. So sometimes the textbook and my webbook talks about the property of a certain type of mathematical relations in general, such as the equivalence relation. And sometimes we'll talk about the specific preference relation. Now, the one preference relation that actually you can derive all the other preference relations from is, and in the text what they use, is this symbol here. Now, it looks like a greater than or equal to symbol, and in fact, if we're considering utility, the utility that will rationalize certain preferences will sort of replace this with a greater than or equal to symbol. But that's not what it is. Okay, we're talking about basically things being contained in other things. This is read as, Tom, do you remember what this symbol is read as? Well, in a sense, but in a preference sense. Okay, there's two things. One, this is a mathematical operator called precedence, but in a preference sense, if if I say x, this thing y, I mean, there's two ways I could say this. I could either say x is weakly preferred, so we call this the weak preference operator, or I could say that x is at least as good as. Okay? And perhaps the concept in sets is that it's either contained in or it's contained in and it's the whole set. Okay? So I have this. So this means that maybe I'm indifferent or maybe I strictly prefer x to y. So it's possible that x is at least as good as y and y is at least as good as x. How would that be possible? They're equal. You're indifferent between the two. You find both of those equally good. And then if x is preferred, is at least as good as y, and y is at least as good as x, we will say one way of writing that is y is indifferent to x, and this relationship, pretty obviously, you could prove it, but this relationship will be what's called reflexive. So if y is indifferent to x, then x is indifferent to y. Okay, and then the third term that we'll occasionally use, and by the way, I never need to use this because I could just always just root it in these things. I could just, rather than saying y indifferent to x, I could say x at least as good as y and y at least as good as x, but that's kind of time consuming. The third one is strict preference. So if x is at least as good as y, and y, and not, I'm just going to use the English term not, and not y is at least as good as x, then we say x is, what would we say? Strictly preferred to y. Okay. So those are the three things that you'll see going around. Let me now talk about some of the properties that we might assume, and if we do assume them, right? So these we say, are these properties reasonable? Well, let's make that like we call that an axiom. Given this axiom, what else holds? What is equivalent mathematically? And even though it's equivalent mathematically, it might be actually very insightful to us. You know, if I see a math equation in algebra and it's a mess, I don't get any insight from it. But once you isolate things on one side, it's often much more informative. Okay. So, what are some things we could say about this relationship? About this, we call this a preference relation. Okay. Now, another thing I want to disambiguate here. I think I got that word from reading Wikipedia. Is that I can say things about preference relations in general, but we're going to also talk about specific preference relations, which we could describe in words, and if we have specific sets of objects, like suppose the things we choose from are numbered 1 through 10, my preference could be I always prefer the thing that has a greater number. Okay, but what we're going to say is what are some properties we might assume about all possible preference relations, and what do those imply? Okay. One, and this is pretty fundamental to economics, it might be controversial in other disciplines, I would say. One is called completeness. Okay, let me pause. Another one will be called transitivity, and those are the two I'm going to focus on right now.